All right, so we want to solve for y on this one. Okay, so we want to get y by itself. Okay, so in order to get y by itself, we need to get this 8 away from this stuff. Okay, so we're going to divide by 8 on both sides. And so that's going to give me x divided by 8 is equal to 10 raised to the y. We still want y by itself, so we're going to do the circle of life. And that's going to give us log of base 10 of x divided by 8 is equal to y. We're going to do something kind of similar on the right-hand side with this equation. We're going to isolate this log by subtracting 15 from both sides. And so that's going to give us x minus 15 equals log of base 4 of y. We're going to do the circle of life, and we're going to set it up as an exponential. So 4 to the x minus 15 is equal to y. Okay, so this you should be pretty comfortable with. If you have a log and you're trying to solve for log of some value, then in order to solve for that, you're going to put that as exponential, right? Okay, so finding the inverse of each function. In order to find the inverse, what's the first thing that we're going to do? We're going to switch our x and y. Okay, so that's going to give me x equals 7 raised to the 2y plus 4. Now, when we switch our x and y, we now want to solve for our y. So the first thing that we're going to do is we're going to subtract 4 from both sides. And that's going to give us x minus 4 equals 7 raised to the 2y. We're going to do the circle of life. So that's going to give us log of base 7 of x minus 4 equals 2y. And we still want y by itself. So we're going to divide by 2 on both sides. So this is going to give me log of base 7 of x minus 4 divided by 2 is equal to y. This one, we're going to find the inverse of this one. We're going to switch our x and y. And then we're going to solve for our y. So we're going to get rid of this 5 because it's attached to this log. So we're going to divide by 5 on both sides. Okay, so that's going to give me x divided by 5 equals ln of y minus 3. Are you finished with your thing? Okay, cool. All right, so this ln is the same thing as log of base e of y minus 3. And now we're going to put this in exponential form because we're trying to solve for y. So we're trying to get y by itself. So this is going to give me e to the x divided by 5 equals y minus 3. I'm going to add 3 to both sides. And so my final answer, and I'm going to write this up at the top so that you can actually see it, is y equals e to the x divided by 5 plus 3. So really quick, just to kind of summarize our steps, the first thing that we want to do is switch our x and y. The next thing that we want to do is isolate either the exponential or the log, depending on the equation, okay? And then the last thing we want to do is solve for y. Okay, so those are the 3 steps that we're going to deal with. And if you kind of just remind yourself of those steps, then you should be okay. So if we ask for the inverse of a function, those are the steps that we're going to use. Okay. So composition of functions. Compositions are where you basically take one function and plug it into the other one. So right here, what happened is we take the original function that's in blue and take the red one and plug it in for that x. Okay, so that's what they did here. After that, we see that there's 3 raised to the log of base 3. These things are going to cancel out because they have the same base. Okay, that means that we're left with x plus 1 minus 1, and 1 minus 1 is going to give us just x. Okay, the way that we're going to check and see if these two functions are inverses of each other is by seeing if it's equal to x. On this next one, they did the same thing. They took the function that's in red and substituted the blue one in. So when they did that, these are going to cancel out, and we're left with x minus 1 plus 1, so left with x. So yes, these are inverses of each other. All right, so we're going to verify that these two functions are inverses of each other. So what we're going to do is we're going to take this function and plug this in for x. Okay, so this gets a little tricky, so I pay attention. Okay, so we're going to title this one the red function, and we're going to title this one the blue function so that we can keep them straight. Okay, so first we're going to write out the red function. And instead of writing x, we're now going to write out the blue function. So this is going to be log of base 6 of 1/4 times x. Well, we see that we have a base here, and the base of this log are the same. So these are going to be able to cancel, and we're left with 4 times 1/4 times x. Well, what's 4 times 1/4? Just 1. So this is going to be y equals x. Okay, that means that these two functions should be inverses of each other, but we have to check it both ways. So what I mean by that is now we got to take the blue function, write it out, and instead of writing x, we're going to write the red function. So what we have here, we have 1/4 times 4, which is going to give us 1. So this is going to give us log of base 6 of 6 raised to the x. Since these are the same bases, they will cancel, and we're left with x. So yes, they are functions, inverse functions. All right, so using composition to determine if the functions are inverses. Okay, so again, I would suggest like kind of making sure that you keep track of which function is which. So first we're going to write out the red one. And instead of writing that x, we're going to write the green function. So that's going to be log of base 2 of x minus 1. And then this red function had that plus 1. So we're going to just add that back in here. Okay. When we simplify, these -1 and 1s are going to cancel out. And we're left with 2 raised to the log of base 2 of x. These are also going to cancel because they have the same base. And so that's going to equal x. Okay. You're going to have to check it the other way as well. So we're going to write out log of base 2 of, and we're going to plug in the red function. And so this is going to give us, when this cancels, we're going to be left with x plus 1 minus 1, which will simplify down to